Assalamualaikum warahmatullahi wabarakatuh. We are from CS1104D. So today we're going to present to you our case study, which is case study 9 for the subject of ITT300, Introduction to Data Communication and Networking. Next is our project organization. IZATI binti AHMAD JOHARI as a project manager. Me, myself, Aqilah Hanis binti NURAZHAR as a network architect. FARHAN bin AZLAN as a network engineer. And lastly, Muhammad Irfan ZAHIEN bin AMIRUZAMAN as a telecommunications manager. Move on to the next part, which is our introduction. Sakura Sendirian Berhad is a local company that provides animation services. They usually provide concept to deliver animation services by discovery, script writing, design, animation, sound, and etc. That everything a polished video requires. However, they don't have a proper network plan for their company. Therefore, we are required to design, set up, and configure the wireless LAN using Cisco Packet Tracer for the company. The requirements they set are they need a hotspot which can connect to 25 laptops and 5 mobile phones for their staff wirelessly. The access point will be connected to the switch via cable. Moreover, the switch will be connected to the router using wired LAN as outgoing sources. Nonetheless, the company also requested our team to set up their web server regarding the company which provides services on animation or other animation activities and events. Last but not least, all the devices are required to be able to access their website as default successfully via wirelessly. As a result, we have decided to design the network topology as shown in the next part to ensure that the system meets the client's expectation and work as required. Next, I will explain a bit about our logical and physical structure for our case study. The company named Sakura Sendirian Berhad asked us to prepare a wireless LAN network. They needed a hotspot that can connect up to 25 laptops and 5 mobile phones. So this is the 10 laptops, this is 10 laptops, and this is the 5, which conclude to be 25 laptops and 5 mobile phones. Put off all the topologies we have researched about, our team decided to use the star topology for this project. We divided device accordingly to avoid the occurrence of bottleneck. By dividing the device to 3 separate APs, will increase the speed and performance of the network itself. A broader bandwidth can be accessible by every devices connected to the each AP with less bottleneck occurrence. It also creates a flexible network for the ease of configuration and maintenance besides providing a future expansion of the network in case more users will be added in the near future. Next, the AP, which is access point, is connected to the switch via cable. Our team decided to use shield twisted cable STP because the shielding reduces the chance of crosstalk and interference. Next, the switch also connects to the router using STP wires. We set up the IP address for the router as 10.0.0.1 with the subnet of 255.0.0.0. Nonetheless, the company also asked us to set up their web server. So we have set up several servers, which is our web server, DNS, and DHCP. The DNS is the domain name system that is responsible for translating those domain names into IP address and leading them to the correct website. We set up a DNS server to ease the user to access the website by only enter the domain name for the website without having to remember the IP address of the web server. Next, the DHCP is the Dynamic Host Configuration Protocol that automatically provides and assigns IP addresses, default gateway, and other network parameters to the client devices. Since all devices connect using wireless connection, as you can see here, we set up DHCP server so the IP addresses will be assigned automatically. This will save time and effort to set the IP address manually every time a new device connects to the network. So let's move on to the website. So let's try to open the website. We go to the web browser and search for sakura.com. And when we click enter, this will appear, the Sakura website. And this is about the Sakura, and we have 3 buttons here, which is our network provider team, projects, and services. So when we click the network project team, it will redirect into this page, our network provider team. So we have IZAHI as the project manager, me as the network architect, AMIR as the network engineer, and ZAHIEN as the telecommunications manager. So when we click the button back, we redirect into the home page. Done with the website. Next, I will try to simulate and try to send emails to check for the response of the network. So when we click the simulation, let's say the laptop 5 try to email to laptop 24. Let's try. So the email is sent into the switch from access point, and it will go into every devices. So it doesn't send into this access point. Let's try look on this. So yep, it's sending to laptop 24. Here also it doesn't send to any of the device here. So from laptop 24, it will send back into the sender. It means it reply back the emails. So yeah, the laptop 5 receives the email. So let's stop the simulation. So that's all for the explanation of logical and physical structure. I'll pass to Zahien to explain more about it.
Hello, my name is Muhammad Ifazani bin AMIRUZAMAN. I am going to explain about our design in this project. So this is a physical structure. Next is network topology. We use a store topology. Each node, such as laptop, mobile phone, and server, is connected directly to the switch in the store topology. It is one of the most widely used networking platforms. It consists of a number of devices or computers that are all connected to a single centralized computer. If a link fails, it bypasses the hub. The remainder of the session can continue to operate, and adding and removing workstation is easy with a star topology. For the transmission media, we use a STP cable. STP stands for Shaded Twisted Pair to connect the device in this project. Each of the 4 twisted pairs in this cable is wrapped in metal files. The 2-layer barrier protects STP from electromagnetic noise, allowing it to communicate over greater distance. Network and connecting device. For router, we use Cisco 2911K9 because it is built with a high availability designed for maximum network uptime and redundancy. Switch, we use Cisco WSC296024TTL. Improved hardware and software allow for more advanced software options and access control on a bigger scale. Lastly, for the server, we use Lenovo ThinkSystem ST50, suitable for server for a small to medium-sized corporation.
Hi, my name is IZATI binti AHMAD JOHARI, and today I will be explaining about the cost of implementation in our project. So the first one is the network devices and cabling. In Sakura Sindiran Company, we use this type of switch which is from the Cisco brand. This is the picture of the Cisco switch. We use the model Cisco WSC29 CS1104D, which have 24 ports and the flash memory is 32 MB flash. This switch costs us 2,000 ringgit per unit. In our project, we use only one switch, so it costs us only 2,000. So for the router, we use the same brand, which is the Cisco, and the model is Cisco 2911K9 Integrated Services Router. It have 491, 532K or 32,768 KB of memory. So this router costs 7,376 ringgit per unit. In this company, the Sakura Sendirian Pet company, we use only one router. So it only costs 7,376 ringgit. So the third one is the access point. We use brand name D-Link, and this access point, the model is DAP1360 wireless 300 mN access point. The connectivity speed is 300 Mbps. Also, this access point provides 64 or 128-bit of WEP encryption and WPA or WPA2 security to protect your network and wireless data. So this access point, we use the wireless one because the Sakura Sendirian Pet company need to use laptop and handphone, so we need to use the wireless one. And this access point costs us 90 ringgit per unit, and in our project we use 3 unit of access point, so it costs us 270 ringgit, 70 ringgit. And for the cable, we use STP, which is shielded twisted pair with RJ45 connectors. This is the picture of the cable. This cable is from brand Tiny Tech category 7. This one is 10 meter one, and it is up to 10 Gbps transmission speed with increased frequency of up to 600 MHz. So megahertz, sorry. We use this cable because the transmission speed is laju, and also this cable costs us 62 ringgit per 10 meter, and in our project we use 100 meter, so it costs us 620 ringgit. The second one is hardware requirement. This hardware we use is server from brand Lenovo. The model is Lenovo ThinkSystem ST50 Tower Server. The memory is 8 GB, DDR4 RAM. Then the storage is quite big, which is 1 terabyte. With this server use processor Intel Xeon E2144G. And this server costs us 5,609 ringgit per unit. And in our project, we use 3 unit of server, so it costs us 16,827 ringgit. And the third one is software requirement. In this Sakura Sendirian Pet project, we use Google Cloud for the storage because the Google Cloud platform offers application development and integration services. Also, Google Cloud have Google Compute Engine. This is for workload hosting. Also, it have Google Cloud Storage. This is to store large data and unstructured data sets. And last one is the Google App Engine. This Google App Engine is to develop software and products. This Google Cloud costs us 1,272 ringgit. And the last one is the installation and other services. This is the picture of the guy install the network devices and cabling. These services is by other teams company to install network devices and cabling services in Sakura Sendirian Pet building. So the network devices that they need to install is the access point, router, switch, and the cabling services is the STP cable. And we sum up that the installation cost us maybe 18,260 ringgit. And this is the total cost of the implementation. The network devices and cabling, which is cost us 10,266 ringgit. That have one switch, one router, 100 meter of cable, STP cable, and 3 access point. And the hardware requirement costs us 16,827 ringgit, which have 3 unit of server. And the software requirement costs us 1,272 ringgit. And last one, installation and other services cost us 18,260 ringgit. And the total cost is 46,265 ringgit. Okay, that's all from me. I will pass this to FARHAN to explain about strength and weaknesses.
Hello, my name is FARHAN. I'm going to explain to you the strength, the weaknesses, and also the recommendations for our network system. The first strength for our network system is the resistance to interference. The network system can avoid being interfered by outside sources such as electromagnetic forces, and it is automatically repelled by the metallic foil around the wire of the shielded twisted pair cabling, or the STP cables. The second strength is the STP cables can transmit data quickly at speeds up to 100 megabits per second. This will boost the productivity of the network itself. The third and last strength is the use of star topology. The star topology is a very reliable topology as it can still work even after one of the devices fails to function. Moreover, it has reduced chances of data collision as it has a high performing topology and it prevents unnecessary passing of data packet through node. As for the weaknesses of the network system, it is not a budget friendly system because the cost of the STP cables is high as the STP cables themselves are shielded from interference. The star topology network also is not a budget-friendly choice because it uses a lot more wiring than the usual network topology, so it will cost more than the usual network system. Moreover, the network system itself has signal instability. The wireless connection from the access point to the laptop uses air as a transmission method, so it is not very stable. Moreover, wired connections are faster than a wireless connection. Finally, the hub is a very crucial part of the star topology because it is the heart of the topology itself. If it fails, the whole network will fail and the network itself will be unable to function properly. For the project recommendations, based on our observation and thorough investigation into the difficulty of our project, we discovered that utilizing fiber optics to solve the problem is a lot easier than using the STP cables, which require a lot of maintenance and it is expensive to install in an office. Furthermore, adopting fiber optics allows for a significant increase in bandwidth for the office network system. Fiber optics has a disadvantage in that the cable must be a small distance from the transmitter because it requires repeaters to deliver data across vast distances. Furthermore, fiber optic cables are also brittle than traditional wires. And so our team will recommend that we will upgrade the system by using more hardened wires in the future.